Okay, good morning students. Shall discuss the examples of Raabe's test. Examples on Raabe's test. First example, discuss the convergence First example, 1 plus 1 divided by 2 plus 1 by 2 into 3 divided by 4 plus 1 by 2 into 3 by 4 into 5 by 6 plus is the given series. Test the or discuss the convergence. First we take un and un plus 1 term. First we take the un term. Here un is equal to nth term is 1 into 3 into 5 into 7 like that. 1 into 2 into 3 into nth term 2n minus 1 n equal to 1 minus 1 2 ಅಂದ್ರೆ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ 2n minus 1 n equal to 1 2 into 1 1 minus 1 okay divided by denominator 2 4 6 8 10 like that 2 into 4 into 6 2n n equal to 1 fill the n equal to 1 2 into 2 4 2 into 3 6 like that. This is the un term. Next take the un plus 1 un plus 1 take n equal to n plus 1 1 2 3 n equal to n plus 1 2 n plus 1 minus 1 divided by 2 into 4 into 6 2 n plus 1 take n equal to n plus 1. This is equal to 1 into 2 into 3 2 into 2 into n 2n plus 2 minus 1 2n plus 1 divided by 2 minus 1 is 1 okay 2 into 4 into 6 into so on 2 into n 2n plus 2 2n plus 2 is the un plus 1. Next applying the D'Alembert's ratio test. First we shall apply the D'Alembert's ratio test. That D'Alembert's ratio test is fails. Next apply the Raabe's test. Okay. Applying condition of D'Alembert's ratio test. Limit n tends to infinity. D'Alembert's ratio test is un plus 1 divided by un. n plus 1 divided by un is equal to finite quantity. Okay, un plus 1 is 2 take the last term 2n plus 1 divided by 2n plus 2 un plus 1 un whole divided by un is this term 2n minus 1 divided by 2n. Take in the reverse multiply. Limit n tends to infinity. un plus 1 is 2n plus 1 divided by 2n plus 2 into taking the reverse 2n divided by 2n minus 1. Okay. Next, applying the limit n tends to infinity. Take in this term n outside, n into this term n into 2 plus 1 divided by n. Taking n outside, n into 2 to n, 2n into n cancels 1 out. Divided by, here also take n outside, 2 plus 2 divided by n into n into 2. Here also take n into 2 minus 1 by n. N cancels, here also n cancels. Next step. Limit n tends to infinity. First one, 2 plus 1 by n divided by 2 plus 2 divided by n into, here 2 divided by 2 minus 1 divided by n. Okay, applying limit, this implies applying the limit 2 plus 1 divided by infinity, 2 plus 2 divided by infinity into 2 divided by 2 minus 1 divided by infinity. This implies 2 plus 0, 2 plus 0 into 2 divided by 2 minus 0 is equal to, or this implies 2 divided by 2 into 2 divided by 2 cancels, equal to 1 is equal to L, given finite number. Okay, applying the D'Alembert ratio test, equal to 1 equal to L, L equal to 1, the D'Alembert ratio test fails. Therefore, L is equal to 1. D'Alembert's ratio test fails. D'Alembert's ratio test fails. Next, applying the Raabe's test condition. This test is fails. Next, apply the Raabe's test condition. Raabe's test condition is limit n tends to infinity, n into un divided by un plus 1 minus 1 equal to L. This is the Raabe's condition. Applying this condition, here un divided by un plus 1 minus 1 equal to, take this condition, un plus 1 divided by un equal to, already known the condition in the D'Alembert's ratio test. Reverse this condition, un 2n plus 2 divided by 2n plus 1, reversing the element minus 1. You know the value of un divided by un plus 1. In the D'Alembert's ratio test, un plus 1 divided by un. Reverse, taking the elements reverse. Okay, solve this. This implies 2n plus 2 multiplying this minus 2n minus 1 divided by 2n plus 1. 2n 2n cancels. This equal to, or this implies 1 divided by 2n plus 1. This is the un divided by un plus 1 minus 1 element. Now taking the n, multiplying throughout by n, un divided by un plus 1 minus 1 into n equal to, multiplying n means n divided by 2n plus 1. 2n plus 1. The next applying limit in this term, limit n tends to infinity, un divided by un plus 1 minus 1 into n equal to n to 1, take n outside, n into 2 plus 1 divided by n, and n cancels. Also write the limit condition, n tends to infinity. Next, applying the limit 1 divided by, this implies 1 divided by 2 plus 1 divided by infinity. This is 1 divided by 2 plus 0 equal to 1 divided by 2 equal to L. L is less than 1. In the Raabe's test, L is less than 1. Summation of un is divergent. Therefore, summation of un is divergent if condition is if L is less than 1. Raabe's test ನಲ್ಲಿ ಏನಾದರೆ L is less than 1, summation of un is divergent. This is the example in Raabe's test. Next one, next example, x divided by 1. Example 2, x divided by 1 plus 1 divided by 2, x cube divided by 3, x cube divided by 3 plus 1 divided by 2, 1 divided by 1 by 2, 3 by 4, 3 divided by 4, x raised to 5 divided by 5 plus, next term, 1 into 3 into 5 divided by 2 into 4 into 6 into x raised to 7 divided by 7 plus continuing. This is the given series. Here also take first un and un plus 1, applying the D'Alembert's ratio test. D'Alembert's ratio test fails, next apply the Raabe's test. Here un is equal to, un is the nth term, is equal to 1 into 2, 1 into 3 into 5, so on, 2n minus 1. Here also taking the one term x, x is there because that into x raised to 2n plus 1. Take the x raised to 2n plus 1. Take the n equal to 1. N equal to 1. 2 into 2. Sorry, 2 into 1. 2 minus 1. Okay. Next, x equal to 1, 2, 3. Okay. 2 first term is minus. Rejecting. After first term, after the first term, or rejecting first term. First term ಬಿಟ್ಟ ನಾವು ಉಳಿದಂಥ series ಅನ್ನು nth term ಆಯಿತು, because first term is not coming. Okay, un divided by here 2 into 4 into 6, same 2n. Here also 7 term is there, 7, 9 like that. N plus 1th term is nth term 2n plus 1, 2n plus 1. Here also take n equal to 1, 2 into 1, 2 plus 3, x cube divided by 3. Okay, n plus 1 term 1, 3, 5, so on. Taking the n equal to n plus 1, this is 2n plus 1 minus 1 divided by 2n plus 1. Okay, n equal to n plus 1. Here also x raised to 2 n plus 1 plus 1. Okay, n plus 1 plus 1, n plus x raised to 2 n plus 1 plus 1 divided by denominator 2 n plus 1 plus 1. Take this. Here also denominator side 2 into 4 into 6. Next condition is limit n tends to infinity un plus 1 divided by un. D'Alembert's ratio test. Un plus 1 is applying this or simplifying this term. This term is 2 into n, 2n plus 2 minus 1, 2n plus 1 into x raised to 2n plus 2, 2n plus 3. In this side, denominator 2n plus 2, 2n plus 2. N equal to 2, 2n, 2. Okay, here also x raised to 2n plus 2 plus 1. N equal to n plus 1, 2n, 2. n plus 3. Okay, this implies applying the limit un plus 1 divided by un plus 1 is this 2n plus 1 x raised to 2n plus 3 divided by 2n plus 2 into 2n plus 3. Reverse the unth term. See 2n minus 1. Reversing this term, 2n is the upper side numerator. 2n plus 1 divided by 2n minus 1 into x raised to 2n plus 1. Okay, next applying the limit n tends to infinity un plus 1 divided by un plus 1 divided by un equal to, also applying the limit n tends to infinity. Take the n outside. Here 2n plus 3, 2n plus 1. this term as it is. Write the again another step, 2n plus 1 divided by 2n plus 2 x raised to 2n to x raised to 3 divided by 2n plus 3 into 2n divided by 2n minus 1. Here 2n plus 1. Here x raised to 2n, x raised to 2, x raised to 2. Cancels x raised to 2 term. Here also x square, x cube is there, x square into x, x square into x. Take like that, x square into x. X raised to 2n, 2n cancels. X square means this is x cube, x square into x. 1 x square cancels. Okay. Next we get the applying the limit n tends to infinity. In this term, taking n outside, n into 1, n into 2 plus 1 by n. 1 divided by n divided by n into 2 plus 1 divided by n. In this term, x raised to 2n, x raised to 2n cancels. Plus 3 is x cube. Here also one term is x divided by n taking outside 2 plus 3 divided by n into, in this term, 2 into n. We are taking the n outside, n into 2 minus 1 divided by n. Here n into 2 divided by 1 plus n. Here the x square, these terms are cancels. N cancels. Next other terms, these terms are cancels. Next, applying the limit n tends to infinity means these terms are infinite or equal to 0. 2 divided by 2 first term into x divided by 1 into here also 2 divided by 2 is remaining, here also 2, here also 2 divided by 2, these are cancels, equal to, this is equal to x, taking the x. X is not finite quantity, then we assuming x is less than 1 condition, x is greater than 1, x equal to 1, x equal to 1, 3 conditions. First condition, x is less than 1, summation of un is convergent by D'Alembert's ratio test. X is greater than 1, summation of un is divergent. Next condition, if x equal to 1, D'Alembert's ratio test fails. Applying the Raabe test. Let x equal to 1, the ratio test or D'Alembert's ratio test fails. D'Alembert's ratio test fails. Next, applying the Raabe's test. Raabe's test, first un plus 1 divided by un is the term 2n plus 1 raised to 2 divided by 2n plus 2, 2n plus 3. Taking this term into x, x equal to 1. Here also into x is the term, x equal to 1. Okay. Next, un divided by un plus 1. Reverse the element. Minus 1. Taking as minus 1 both sides. 2n plus 2, 2n plus 3 divided by 2n plus 1 bracket square minus 1. Minus 1. Next, multiply this term. 2n, this implies 2n plus 2 first term, 2n plus 3. Next, minus of 2n plus 1 bracket square whole divided by 2n plus 1 square. Simplifying this, 2n plus 2 or multiplying 2n into 2n, 4n square plus 6n, 3 into 2 6n plus 4n plus 6 minus of this term a plus b bracket square. A square means 4n square minus sign 2ab, 2 into 2 4 n minus 1. This square is minus 1 whole divided by 2n plus 1 bracket square. Here 4n square term, 4n square, 4n cancels, 6n, 6 plus minus 1. This is equal to remaining term 6n. Here 6 minus 1 is 5 divided by 2n plus 1. Here 5 bracket square. Okay. This is un divided by un plus 1 minus 1 equal to this term. Multiplying n in this side also, multiplying n, 6n plus 5 into n divided by 2n plus 1 bracket square. Okay, applying limit n tends to infinity, un divided by un plus 1 minus 1 into n is equal to n into n square into 5n, n square 6n square plus 5n divided by 2n plus 1 bracket square. Okay, applying limit n tends to infinity, un divided by un plus 1 minus 1 into n is equal 6n square plus 5n divided by, expanding this term, 4n square plus 4n plus 1. A plus b bracket square. A square means 2 into 2 4, n square, b square is 1 square is 1, 2 into 2n is 4n. Limit n tends to infinity, un divided by un plus 1 minus 1 into n equal to, applying limit this side, limit n tends to infinity, take the n square outside, n square taking outside, 6 plus 5 divided by n, 5 divided by n. In this side take n square, 4 plus 4 by n, 1 by n square. Okay, limit n tends to infinity. Here n square cancels, 6 plus 5 by n. Here 4 plus 4 divided by n plus 1 by n square. Okay, next applying the n tends to infinity limit. N tends to infinity, take the n equal to infinity. 6 plus 5 divided by infinity, 4 plus 4 divided by infinity plus 1 by infinity square equal to 6 divided by 4. All terms are 0. Here 6 by 4 means n equal to 4 ones are 4, 1.5. 1.5 is greater than 1. Here L is greater than 1. L is greater than 1. Raabe's test is convergent. Therefore, summation of un is convergent if L is greater than 1. Okay, this is the example number 2. Okay, next class discuss the other examples.